Hi, I'm NMurphy, and I am a graduate student in the Department of Astronomy. Today I'll be giving a presentation on LaTeX. And there are slides that go along with this presentation, which are available on the website. And they were actually made using LaTeX, which will just show you an example of what LaTeX can do. LaTeX is a text processing language, which is used often by mathematicians, scientists, engineers, and many others. It was developed from the TeX typesetting language, which was created in the late 1970s and early 1980s by Donald Knuth. And LaTeX was developed by Leslie Lamport as an extension of TeX in the mid-1980s. So the goal of LaTeX is to allow the production of high-quality, professional-looking documents while minimizing the effort spent on typesetting. So on slide 3, I talk about the advantages and disadvantages of LaTeX. So the main advantage of LaTeX is that you can produce professional-looking documents with relative ease. The math is typeset beautifully. It's freely available, highly portable, and stable. It's used by most professional scientific journals. So if you're going to have a record of publishing, then you probably want to learn it. And the focus is on the content rather than typesetting. LaTeX does the typesetting for you. But there are some disadvantages. The first is that there's a learning curve. In Microsoft Word, what you see is what you get, but this is not true for LaTeX. You cannot click and drag, and specialized formatting can be a bit difficult. And one annoying thing is that you often have to debug your documents, which you usually wouldn't have to do in Microsoft Word. On slide 4, I've typeset several fundamental equations of physics just to give you an example of what LaTeX can do. Okay. So to develop a LaTeX file, you create a .tex tex file using your favorite text editor. On Unix or Linux, you can use Emacs, VI, or Nedit, TextShop for Macintosh, or WinEdit or Notepad for Windows. Microsoft Word usually won't work. If you're on a Unix prompt and you want to run LaTeX, you just type the command latex a.tex, or just the file name .tex. And if you want to view the output, you just do xdvi a.dvi. And you can use the dvi-ps or dvi-pdf commands to convert it to a PostScript or PDF file, since the DVI is just the raw output. But you can also use PDF LaTeX. And there are also other extensions which you're able to find on the web. On slide 6, I have an example of a very simple LaTeX document, the equivalent of a Hello World program. So the first command in that is \document class article. And that pretty straightforwardly just says that article is the class for this document. Between the document class and begin document commands, there is what is called the preamble, and it's there that you'll include or load any packages or declare any global commands. And you'll include the text between begin document and end document. And if you want to have a comment, then you just start that with a %sign. Okay, so document organization is very straightforward in LaTeX. You can have commands like \chapter, \section, and \subsection. And there's an example on slide 7. And LaTeX will take care of the numbering automatically, which is very nice when you have a long document. And one other thing worth mentioning is that to start a paragraph, you just leave an extra blank line in between 2 paragraphs. So one important thing to learn about LaTeX is how to use math mode. And there are a couple of ways to get into math mode. If you're doing an inline equation where the equation or the math appears within a line inside a paragraph, then you just use $signs. So $sign equals MC caret 2 $sign yields equals MC squared just within a line. If you want to have a displayed formula, which would appear as its own line, then you do \begin bracket equation close bracket, and then just have the math, and then use end equation after that. And that'll give you whatever math as a separate line, and it'll take care of numbering too. If you have an array of equations, then you can use the equation array, EQN array environment, instead of the equation environment, and that'll give you multi-line equations quite nicely. And there are other math environments which you can use which have subtleties regarding equation numbering, which you can look up on your own time. Okay, so on slide 9, I have some examples of that you can, within math mode. For superscripts and subscripts, it's pretty straightforward, just a caret or an underscore. And you can even have subscripts within your subscripts or superscripts if you want. There are also fraction commands, frac, roots, integrals, sums. Greek letters are always in math mode, operators, and relations. And then for functions, for a lot of functions, there are special commands. Like if you do \cos, then that'll actually typeset it in a math Roman font. So it'll appear not as variables, because if you just do COS, then LaTeX will think of them as variables. On slide 10, I talk about the automatic sizing of brackets. And one of the things that people starting out with LaTeX often do is just have a parentheses on either side of a fraction. And if you don't use the \left and \right commands around a fraction, then you won't get correct sizing. And you can use them for parentheses, brackets, the absolute value vertical line things, and whatever else you want them to. Okay. So to create a matrix, you'll need to use the left and right commands also. And then within math mode, you can just use the array environment. And on slide 11, if you look at where I declare begin array, then the CC corresponds to centered. So that controls the alignment. And the ampersands align the individual elements within the matrix, and the double backslash breaks lines. So that matrices and arrays are pretty straightforward, although they can be a bit time consuming if you have about 20 by 20 elements in them. If you want to include graphics, LaTeX most readily accepts PostScript files, encapsulated PostScripts, and PDF files. There may be ways to use other formats, but these ones are probably the easiest, and most journals will usually request EPS figures anyway. But if you have another file format, you can often use software like the new image manipulation system called GIMP, which you can use to open a bitmap file and then save it as a PostScript or an EPS. But if you have a vector graphic, you generally should never convert it to a bitmap, since vector graphics the objects are defined mathematically, so they have infinite resolution. So the process of including graphics, usually you want to declare in the preamble of the tex file, use package graphics, so that you can actually do that. Okay. So the simplest way to include graphics is to use the include graphics command. And there are several keywords within that you can use to scale it by a certain factor or to rotate it in one direction or another. And then you just include the file name for the PostScript or EPS or PDF file. If you're doing a document or article or report, then you probably also want to do this within the figure environment. And that way you can include a caption, which makes things a lot more clear. One thing that LaTeX really does well is that if you include what's called a label, and then you have a tag for the label, you can refer to the label later on using the ref command. And so if you have a figure and you include label, and then in the text you say, in figure \ref and then the label name, then you can get the number of that object to appear. So if you have a huge document like a PhD thesis, then this works really well, and it saves you a lot of time compared to Microsoft Word. And you can also do this for sections, subsections, chapters, equations, and all sorts of different objects. LaTeX can be used on a variety of operating systems: Linux, Macintosh, Windows, and installing LaTeX for a given operating system, you probably just want to look up online the instructions. They should be readily available. If you're using Linux, then more often than not, LaTeX will be included. But for Windows, you probably want to look up the MikTeX package, which is most commonly used. So on slide 15, I just give you a few suggestions for using LaTeX. So the best way to learn LaTeX, as with any programming language, is to just use it often. And you can use it for math homework, lab write-ups, and even English term papers. It takes a while to get started, so you don't want to start something the night before. And since it is a language that you have to compile, you want to compile early and often so that you don't have to debug 10 things at once, and it's a lot easier to actually just isolate the errors. Document organization is important, especially if you have a larger document. If you have complicated equations, then you probably want to break it up into multiple lines within the text file, because then it'll be a lot easier to correct. If you want to make a presentation, two examples are the Prosper and Beamer classes. And Prosper is actually what was used to make the slides for this presentation. But Prosper's simple to use, but if you want to do something flashy, then Beamer is probably the best choice. And last, if you want to use the BibTeX, if you want to make a bibliography, then the BibTeX package does that really well, and you can look that up in pretty much any LaTeX book. All right, and best of luck using LaTeX.